Hey everyone. For those who didn't catch my first introduction, I'm Benji Lampel. I'm an Airflow engineering advocate here at Astronomer. I do a lot of work with integrations and open source. And we have Tamara here, who is going to be giving this Astronomer Live webinar. So what this Astronomer Live are more short form and code focus, and we're going to just dive into a real life example of different products and features that Astronomer is working on. Today, we're going to be looking at data-aware scheduling with the Python Astro SDK, and tomorrow's going to tell you all about what that means. Feel free, as we're going, to leave questions in the chat, and we'll answer them at the end. And you will get all the slides and code emailed to you after the webinar. So everything that you see will be emailed to you. So without further ado, Tamara, take it away.
Thanks so much, Benji. Let me share my screen. You should see my presentation. All right. And welcome to everyone to this Live with Astronomer on data-aware scheduling with the Astro Python SDK. As Benji said, these lives are more short form, so I only have 2 slides on the concepts, and then we jump right into the code and the demo. First of all, what is data-aware scheduling? You might have heard the term data-driven scheduling or heard about the datasets feature. These terms all refer to the same new feature that was added in Airflow 2.4. So this did not exist at all before Airflow 2.4. So one more reason to get updated. And this feature, in a nutshell, allows you to make your scheduling more data aware. So you, as the DAG author, can now tell Airflow that a specific task is updating a dataset. And that dataset can be a table in a relational database. It can be a bucket in a block storage. It can be any file. You simply put the URI to that dataset in the dataset object, and then you pass it to the outlets parameter of that task. And this tells Airflow, hey, when this task completes successfully, this dataset has been updated. Now, one important thing to note that many people can get tripped up on is the task doesn't actually have to touch that data set at all. So it's simply something that you as a DAG author can tell Airflow about this task. And once you do that, once you define a data set this way, Airflow will start listing them in its datasets tab, and this task will become a producing task to that data set. So whenever this task finishes successfully, this data set will be updated. On the consuming side, you can now schedule DAGs based on updates to these datasets. So you can have a DAG and you want that DAG to run whenever a specific table in Snowflake or in any other relational database is updated. So you can now schedule it, instead of scheduling it on a cron string or on a timetable, you can schedule it directly on this flag that is raised to this dataset. And for that, you simply pass the dataset, the same object with the same URI, into the scheduling parameter. And you can pass 1 or more datasets. If you pass 2 or more datasets, then the DAG will run as soon as all of these datasets have been updated at least once. And just in case you're running something pre-Airflow 2.4, schedule is simply the renamed schedule interval parameter. So it's the same parameter. It just now can also take datasets. Now, the other thing that we are talking about is the Astro Python SDK. And I, of course, don't have time to talk about all the amazing features in the SDK. Very shortly, it's a powerful tool to simplify ETL writing. This is one of the takeaways from today. If you are writing ETL pipelines in Airflow, then please check out the Astro Python SDK. It will make your life so much easier. It has different operators that handle common ETL tasks. And one of the many features is that it adds dataset inlets and outlets automatically to your tasks if you are running in an environment that has Airflow 2.4 or later. So what happens is, if you have a task that uses an Astro Python SDK operator that updates, for example, a table, or it updates a file, the operator or the Astro Python SDK will automatically figure out, hey, this task updates this data set, and it will create this data set within your Airflow environment and define this task as producing to this data set. You can recognize these auto-generated data sets because the URI that is auto-generated starts with Astro and uses the template that is on the screen. So this all happens without you having to do anything. This happens automatically with all permanent tables. But if for any reason you don't want this behavior, you don't want this automatic addition of data sets, then you can turn the behavior off by toggling the environment variable on the screen. Okay, I think it's easiest to understand this if you see it in a real example. So let's hop over into the demo. Quickly refresh. All right, so this is a brand new Airflow environment, and you can see I have 3 DAGs here, extremely creatively named Producer DAG and Consumer DAG 1, Consumer DAG 2. Of course, you don't have to name your DAGs according to if they're producers or consumers. They can be named anything. And I'm first going to talk about the last DAG here, the Producer DAG. This is a regular DAG that runs on a daily schedule, so it would run at midnight every day. And it has 3 tasks that run an ETL pipeline. Let me show you the graph. So on a very high level, what this ETL pipeline does is, first of all, you can see the operators I'm using: append operator, cleanup operator, load file operator, and transform operator. Those are all operators of the Astro Python SDK. In fact, this whole Airflow environment only uses Astro Python SDK operators, but of course you can combine them with other operators too. And you can see I have these 3 tasks down here. I have the load file task. This task will take a CSV that I have in an S3 bucket and load it into a table in a Snowflake database. With this action, it updates this table. So this will be the task that produces to the first data set. And then the second task is our transform step. In this case, it simply joins together data that was just loaded into the new table with data that's already in another table in Snowflake. And this will store this data in a temporary table. And my last task, which would be the L in ETL in this case, is taking this data in the temporary table and adding it to an existing table, which is the reporting table. So we have 3 tasks, a simple, very, very simple ETL pipeline. And this 4th task here, cleanup, this is something that's Astro SDK specific. This is simply a task that will run and watch, and after the whole DAG is run, it will automatically clean up all temporary tables, which is pretty awesome. You don't have to do that manually anymore. So what happens is in the producer DAG, we run ETL, and we will produce to 2 data sets, to one that's on the orders table, which is what the loading file is called, and to one that's called reporting table. Now, if I hop back, you can see my 2 consumer DAGs. They both only have 1 task in it. And in the consumer DAG 1, that task runs an operation on that first table, on the orders table, which means I want this DAG to only run once that orders table has been updated. So you can see here the schedule of the DAG isn't a time-based schedule, but a dataset schedule. And you can see the next run. If I hover over here, you can see which dataset it's actually waiting on. You can also click on it, and then you can already tell this was a dataset that was automatically, the URI was automatically generated by the Astro SDK, and it's the orders table in my Snowflake connection. The second DAG is very similar, but it runs a task that uses data from 2 tables. So I only want this DAG to run once both of these tables have been updated at least once. So I scheduled it to happen after both of these data sets have been updated. Now let's look at the code that creates these DAGs. First, I'm going to run through the code for the producer DAG. You can see here, these are my package imports. This is the line 3, where I import the Astro Python SDK after I have provided it in the requirements. And I'm aliasing it as AQL. This is just a convention that we made in the community. I'm also importing the file and the table object. Then I'm defining a few variables, the names of my tables, names of my connections. And next, I'm defining a transform step. So as you can see, I have the AQL package, and I'm using the transform operator in its decorator form. The Astro Python SDK has a ton of decorator versions, and this will simply turn any SQL query that is returned by a Python function into an Airflow task. So what happens is I can call this function with two tables, first and a second table, and then the function will join these two tables in the way that is defined in the SQL query. Of course, you can use SQL queries as complicated as you want them to be. Now I'm instantiating the DAG. I'm running it on a daily schedule. And now we can look at the ETL tasks. So these are the free tasks that create this free task ETL pipeline. The first one uses the load file decorator. This is the load file task. And this will take an input file. So it takes this file in an S3 bucket that I have stored. It uses my connection ID to this to the AWS instance. And I tell it the output table, so where I want this data to live, is the Snowflake instance that I have defined in the Snowflake connection ID, and I give it a name. The name of Snowflake orders is orders table. And if you ever have written ETL pipelines in Airflow, then you can already tell that this is taking a ton of work off my plate. You can see I'm not defining or creating any temporary tables. I'm not having to delete any temporary tables or even define a schema. It is possible in the load file function to define a schema explicitly, but you don't have to. And this works very well with a CSV file. So this is taking a ton of work off my hands already. And what you also can tell is I did not define an outlets parameter. This is because the Astro Python SDK will automatically be able to tell, okay, I'm loading file from S3 into Snowflake. This means I am updating this table in Snowflake. So let's create a data set. And I've added the data set with the URI up here. Let's create this data set with the URI that includes the table name and define that this task produces to this data set without me doing anything or even thinking about data sets when I was writing this pipeline. The second task uses the join orders customers function that we created up here. And we provide two tables to it. We provide the table that was just where we just added our data to, and then provide another table that is already existing in my Snowflake database. And we run the data on these two tables through the SQL query. This is being stored in a temporary table, and the Astro Python SDK does not create a data set for the temporary table. So what happens next is we want to store this data. So I use it as the source table. Can simply use the same object here for the append function. And the append operator will take any source table and append it to a target table. And I define, again, a table object as my target table. And now the Astro Python SDK, being very smart, looks at this and thinks, okay, we have a permanent table, the reporting table. You can hover to see the name, reporting underscore table. And this task is updating this table. So we want to create a data set, and this again all happens automatically with this URI and define that this task is updating this data set. Lastly, I just add the cleanup function. And there's two things you can see here. It has become a ton easier to create an ETL pipeline. And also, I am not defining any dependencies explicitly, because that is another great feature of the Astro Python SDK. It figures out by itself that if I'm using the output of this first task in the second task, the first task has to happen before the second task. So I don't even have to define the dependencies. All right, so I created a producer DAG without even thinking about datasets so far. The only thing that you have to do if you want to use datasets with the Astro Python SDK is do a little bit of work on the consuming side. So if I hop over here, this is our first consumer DAG. We import our packages again, and we especially import the table object again. And now I can define the dataset. Now, if you used the datasets feature before, you will be used to define the dataset by using the dataset class and then providing the URI. You can still do that the same way. So I could uncomment this line and use it. Or if you're using the Astro Python SDK, you can also simply pass a table object directly to the schedule. Because if you're using the same connection ID and the same table name on the table object, it will point to the same URI and to the same data set. So with this line of code, I'm defining my data set, and then I simply offer it to the schedule parameter. And this means that this DAG will only run once this data set has been updated, which is good because this DAG actually uses the data in this orders table. You can see here, I pass in the table object into a task defined with the data frame operator. Unfortunately, don't have time to talk about this in detail, but this is another amazing operator in the Astro Python SDK because you can simply point it to a table in Snowflake or like your relational database that is supported, and it will turn this into a pandas data frame. So you can use pandas logic on it. In this case, just very simply to sum up a column. All right, the second DAG, that's a consuming DAG, almost the exact same story. This time we want to schedule the DAG on 2 data sets to be updated. So only once both of these data sets have been updated, at least once, this DAG should be running. So I'm passing those 2 objects. And I, again, can define these dataset objects simply by providing the same table object with the same connection ID and the same name. If for any reason I would want to use a different, like I wouldn't want to use the table object, I can still pass the dataset object. If I use the same URI that has been created by the producing task, it will still connect these 2. And in this case, I'm using basically the same operation, but I'm doing it on both tables. This is why I only want this DAG to run once both tables have been updated. One important side note, it is not necessary that you actually do anything with data from the data sets that you're waiting for. So I could use a completely different pipeline down here, and I could have tasks that have nothing to do with these data sets at all. So this is simply a way for you to schedule a DAG to run once a data set has been updated, but this could also just, for example, trigger some notifications or something like that. All right, so 2 more things to show you. First of all, I want to show you the datasets view. If you used datasets before, you will have seen this, but you can actually see in a graphic interface what the dependencies between your DAGs and your datasets look like. So we have the producer DAG, and within this DAG, 2 datasets are being produced to, the orders table and the reporting table one. And then we have our consumer DAGs. And consumer DAG 1 is scheduled to only run once the orders table datasets has been updated. And consumer DAG 2 needs both of these datasets to be updated to run. You can also click in here and you see how during my practice runs, I was running these DAGs and how the datasets were being updated and how they triggered their runs. Okay, then let's do that. Let me quickly refresh. If you're using datasets, always make sure that your consumer DAGs are also unpaused. And then you can see we have 7 runs so far. So let's trigger our 8th run of the producer DAG. If you remember, once the first task of this DAG finishes, this first consumer DAG should start running because it's waiting on this data set about the orders table. So if we hover, you can see that which data set it's waiting on. And once it finished, it started running. So this is working great. Now our consumer DAG 2 is still waiting on its second data set. The first one has updated, the second one not. And this will be the 3rd task, has completed. And now this DAG starts running. So you can imagine how you can make your DAGs much more dynamic if you don't have to think about when to schedule them anymore and can simply say, once the dataset is updated, I want to run this DAG that does operations on data in this dataset. All right. With that, I hope I got you interested to learn more. Those are the two big takeaways. Datasets are amazing and the Astro Python SDK is amazing. We have a ton of other material and the slides will be sent out to you. One thing I want to point out, if you haven't used the Astro Python SDK at all yet, I recommend you go through the tutorial. You will find the DAG in the tutorial eerily similar to what you have seen just now. I used that DAG as a template to build the demo. And also watch the Astro Python SDK webinar if you want to see side-by-side comparisons about traditional ways of writing ETL pipelines and using the Astro Python SDK. So with that, I thank for your attention and let's see if there are any questions.
There are 3 questions, and I know that we're already very, very low on time. So I'm going to try and get through them quickly here. The first 2 kind of play off each other, so I'll answer them kind of together. The first question is, what makes the dataset aware scheduling different from an Airflow sensor? And the other one is, any limit or best practice on the number of datasets created? Let's say I have several hundred Snowflake tables. Is it fine to create respective numbers of these tables, I think, as tasks is the assumption, or to use them as dataset aware scheduling datasets? So what makes the dataset aware scheduling different from a sensor is that a sensor takes a worker slot, and dataset aware scheduling is more like a push function. So it's not taking one of your slots in your scheduler. And so that kind of, feeds into the other question of, it is a scalable solution to use dataset aware scheduling on lots and lots of tables, because you're not taking out extra worker slots waiting for those updates. That'll all be pushed. So I hope that answers that question.
Yeah, and I want to add one thing. It doesn't completely replace sensors, because a sensor can still wait for an event to happen. Like, for example, you can have a sensor that looks at a blob storage and you wait for a file to happen. And if you're using datasets, the action that updates the dataset needs to happen in your Airflow, because Airflow will know that the dataset is updated if you have defined the outlets parameter, or if you use the Astro Python SDK and the outlets parameter was defined automatically. But it can't tell events happening in external tools without the event being triggered by Airflow. So that's a big difference. And of course, what Benji said, it makes it a lot easier and cost effective to run, because you're not taking up worker slots.
And so the last question is, what if I depend on data from some other team and they use a different Snowflake connection? If I'm using Snowflake default and they're using Snowflake foo, then will that still work?
So you're saying, like, in the same Airflow environment, you're using different connections? So the automatically created dataset by the Astro Python SDK will use the connection name in it. So my big question would be, why are you using a different connection in the same Airflow environment? Maybe there's a way around that there. But if it points to a different database or a different schema, then it's a different data set that's being updated. But if you still want to use the feature, you can actually define a data set just by yourself. Like, I can quickly.
Well, I think we had a little more context to this too. There is the context here is, if it's coming from another team. So I think there is a good use case for having different connections. I will say also that the data object that's being tracked in Airflow is an update in the Airflow metadata DB table. It's not actually looking at the underlying table right now to be updated.
Yeah, exactly. That's what I wanted to show here. If you're doing this, not even using the Astro Python SDK in any Airflow environment, you could have a data set and simply have any string that's also a valid URI, and this would be handled as a data set by Airflow right now. The reason that we are saying use a URI is for it to be compatible with potential future features. But if you have a DAG and you have a task in that DAG and you want to schedule another DAG to run once that task has completed successfully, you could simply use a data set with a custom URI like this. And if both teams use the same URI, then it will work, if you're in the same Airflow instance.
We got more questions that came in as we were answering these.
Oh, wow.
Yeah. Can we also do heavy processing with Spark? Nothing about these updates changes how Airflow and Spark interact. So if you're using like Spark on Databricks, you can still kick things off on Databricks using those operators, or however you're using Airflow and Spark together now. This doesn't change that. Can you pull a value from the data set?
That's a good question. I actually don't know that, but since there are objects within Airflow, I would assume that you could. But I'd have to look that up. Like I haven't tried it, but I'm assuming that you could pull the URI, though I would probably define the URI as an environment variable instead and not pull it from datasets, but it's a very interesting question.
Does the pandas data frame run in Snowpark? I don't think so.
No, in this case, not. The pandas data frame is running within the Airflow environment here.
Great. We have a few more here. Can you specify the frequency of running the DAG?
Sure. So currently I have the DAG on a daily schedule. So this would run at midnight every single day if I would just leave it like this. And the other two DAGs simply run whenever their data sets are updated. So in this case, they would also run pretty close to midnight afterwards. But of course, you can have like very complicated dependencies with data sets. So you can have one DAG that is running like every hour and another DAG that is running every day. And then you have a DAG that's scheduled on data sets from both DAGs. And that DAG would only run every day too. So only once all of its data sets have been updated at least once. I know that in the official Airflow documentation, they have a graphic that explains this pretty well.
Okay, great. And then can you use an S3 bucket as a data set?
Yeah, definitely. I actually, in my presentation, I think that's what I used. As I said, you can pass any string to the data set that's a valid URI, that passes as a valid URI. With one exception, you cannot start it with the word Airflow. That's reserved for future purposes.
Okay. Can it be used with or on Redis or with Redis? Oh, here we go. I'm using Redis as an Airflow dataset.
You mean you're updating something in Redis? And
yeah, I think the same answer as the S3, which is as long as there's a valid URI that Airflow can connect to, the answer is yes.
Yeah, it's really, you can think of the data sets right now as kind of waving a flag at Airflow and being like, hey, this task is updating the data set. I named this, and the name currently doesn't really matter that much. Like you could use any string that's a valid URI that parses as a URI because there's a check that makes sure it is a URI. But it doesn't have to actually exist. Like I could put in a URI to a bucket that doesn't exist yet. Airflow doesn't know that. But the reason we have them as URIs and we suggest you use valid URIs is potentially in the future there will be features that parse these URIs and do something more with it.
Okay. And can this dataset aware scheduling work across multiple Airflow environments?
Not yet, but that's actually something that we discussed in the team. Like, would this be possible? How would it be created? How would we do this? Like on Astro, things like that. So not yet, but it's something to potentially stay tuned for.
Okay. I think that's it. It doesn't look like we have any more coming in.
Yeah, I'm seeing one open.
Yeah.
Not sure I'm understanding it correctly.
I'm not sure that that's a question within the scope of this talk.
Yeah, it's probably a question on the load file function, if I'm understanding correctly. Like if you're using the load file function, I'm assuming you mean in this step, if you would pass data from S3 to RDS, how it would handle the index. I'm not entirely sure how it does that, but we actually had a live on the load file function, so it might have been answered there. Or otherwise, you can check out the link that's on the last slide. In the Astro Python SDK read the docs, you can see how indexes are handled.
Okay, and the actual last question really quickly, can I add this update on the existing Airflow Docker? So I'm not 100% sure what is being asked here. If you mean,
maybe you're meaning you're running Airflow in Docker and you're pulling an Airflow image, and you're probably asking about either datasets or the Astro Python SDK. And the answer is my Airflow environment is running on the Astro runtime image, but this image is equivalent to open source Airflow. So if you're pulling an open source image here or a custom image, as long as it's based on Airflow 2.4, the datasets features should work. Airflow 2.4 or later. And to add the Astro Python SDK, you have to install a package. Here, I can simply add it to requirements.txt. I'm actually already outdated. 1.3 just came out a few days ago. If you're using this syntax with having a Docker file and pulling from a requirements file, if you're running Airflow fully locally, not in Docker, you would have to install this package. But you can find install instructions on the read the docs side.
Okay. I think that's everything. Thanks, Tamara.
Yeah, thanks so much, Benji, and thanks everyone for the questions. I think this is a new record for a live in terms of questions, at least the ones that I've been at. Yeah, and I hope you have fun and have a great day, evening, night, wherever you are. Yeah. Bye, everyone.
Okay, bye.